means and how do you write the code of the delete. Riddhi, I'm making you co-host. You can remove those people whose cameras are off by giving them a warning, right? You can give them a last warning and can all of you make sure your cameras are on. Everyone. Okay. Now, when we talk about delete, how do we implement delete in your queue? That is in your circular. So if I say void delete, you have to always name the function as rather than delete, because delete itself is a keyword. Now, when you are inserting in the circular queue, things were okay. But what about when you delete? So first of all, for delete, we will consider that circular queue is in case full. Right now, our circular queue is full. Then what? So first of all, if circular queue is full, we take the condition as, so we know two conditions when circular queues are full. One is front equals to 0 and rear is equal to size minus 1. Everyone agrees,
Yes.
right? So when we are deleting, we have to understand that once the queue is empty, we cannot delete. So when the queue is empty, front equals to minus 1, the deletion is not possible. So we say printf the is empty. Now, if there is only one element, else if your front double equals to rear, that is other than minus 1. That means now there is only one element. So how do you delete? The front equals to minus 1 and rear equals to minus. So the elements are deleted. Now in other case, what if deletion happens? So in almost other case, we know that we need to increase the rear ahead. But rear should be increased in two manners. So supposing if I say rear plus plus, but if rear has already reached the last element, then rear will come to 0. So when you are deleting, we consider front. Now when we increase front plus plus, the first deletion has happened. But what if front has reached size minus 1? Then we have to bring the front to 0. Is this condition understood by everyone? This one, this two. That normally when we delete, right, what happens? We are increasing the front. But if front has reached size minus 1, then at that point of time, we have to bring the front to 0. So check. Front has reached size minus 1 Then for deletion, you have to again bring the front to 0. In almost all other condition, we have to just increase the front plus. So first of all, if the queue is empty, you cannot delete. If both front and rear are equal, then we have to bring them to -1. Else check the front has reached last element, then again bring the front at 0. And in all other case, we will increase the front. Okay. Anybody having a doubt here? You can ask me. Okay. Just take the screenshot of the code. Really post it in the group. Please take the screenshot. Okay. Fine. Now everyone share your screen and please make this delete right away. Everyone. Come on. I want all the 49 screens to be shared. I'll give you multiple rights here. All of you urgently share your screens. Anybody completed? Anyone who has completed?
The display after delete the display is not working properly.
Okay. So, like, in which scenario is it not working? Can you test it and let me know?
Okay, sir.
So test by inserting all the elements, then delete one. So
Okay.
exactly in which scenario it's happening, you can just
Sir,
yes,
sir, if we delete one element, the whole queue is getting deleted.
that should not happen. That means the delete is not working well.
Done, sir.
Okay, who's completed? Name?
Done.
So the display is not working properly in any case.
Who completed? Can you tell me? Someone told me I completed.
Yes, sir, complete.
Name?
Vedant.
Okay, Vedant, can you everybody unshare your screen? And Vedant, you share your screen.
Sir, Karuram.
Yep. And now push, not push, insert, right? You have to name it as insert. Push is in stack. No, it goes in infinite. Okay, I'll explain you. See, by the diagram. See, so when you are deleting, let's say check your queue like this. So the first scenario is that there is no element in the queue. So we say front equals to -1, here equals to -1 in this scenario. So that means if your front is -1 in this case, then the queue is empty, we cannot delete. Another scenario is that there is only one element in the queue. So let's talk the element lying here. In this case, your front equals to rear. Then we will bring both of them to -1. Also rear to -1. Now, the third case is your front has reached the last element, the size minus, and your rear is lying here.
Sir, but front will be at the last only when we delete, right?
Front would be
At the last only when we delete, right? And then we are increasing front.
no. We need to understand in your circular queue, we can delete until the last element is there, right? So it
Right.
might
So
happen that last element is right now this one, and front is moving, and it has moved to rear -1, size -1. So now to delete, we have to bring the front here, right?
no, my question is when we delete, then only the front increases, right? So we are saying 2, 3, 4, 5 elements are there, right? So then front will be at 0.
No, let's say this is deleted already. This is already
Okay.
deleted, and now only because we have inserted, right? We have inserted more elements, 2, 3. So here has gone here, right?
Okay.
Now the front is here. So front is at size -1. We bring front to 0. And that means one element is deleted. Else, in all other case, we'll just increase the front. Delete. Getting it? So these are the three scenarios. Now, if your delete is not working, that means your insert has some problem. That means your insert code is creating some trouble. So check up with your insert code, right? By debugging the value. So 5 minutes I give you, you check, and then I make a fresh program, right? All of you check your programs properly. Anybody who comes to the conclusion, let me know, else we go ahead with writing of the entire book.
Sir.
Who's that?
Sir, down.
Yeah, can you share that?
Yes.
First of all, share the code. Yeah, explain your insert, display and delete. And please everyone don't give the name of delete as pop in queue because queue is different and stack is different. So you have to give the name as insert, delete and display. Yeah, go ahead, Riddhi.
सर पुश फंक्शन पहले एक नंबर जो होता है वो इंसर्ट कर लेगा, उसके बाद फ्रंट स्टार्टिंग में -1 हमने इनिशियलाइज किया है, तो उसके बाद जब फ्रंट इक्वल्स टू 0 और रियर लास्ट में चला जाएगा, जब इंडेक्स लास्ट होगी तब क्यू इज ओवरफ्लो वो एरर प्ले करेगा, डिस्प्ले करेगा। उसके बाद एलसिफ में फ्रंट -1 इक्वल डबल इक्वल्स टू रियर हो तो बने ओवरफ्लो प्रिंट करશે ત્યાં એલ્સિફમાં જો ફ્રન્ટ ઇક્વલ્સ ટુ -1 હશે તો ત્યારે ફ્રન્ટ ઇક્વલ્સ ટુ 0 અને રિયલ ઇક્વલ્સ ટુ 0 એટલે એક એલિમેન્ટ જ્યારે તે સ્ટાર્ટિંગમાં એમ્પ્ટી છે હવે એક એલિમેન્ટ એડ કરે છે બંને 0 થઈ જશે અને એરેના જો ફ્રન્ટ છે એટલે એરેનો 0 ઇન્ડેક્સ છે ત્યાં એ નંબર ઇનિશિયલાઇઝ થઈ જશે, પછી બધામાં રિયલ પ્લસ પ્લસ કાઉન્ટ કરશે અને એના એલિમેન્ટ્સ મળ્યા રહેશે જ્યાં સુધી એની સાઇઝ હશે કે યુઝર જ્યાં સુધી માંગે ત્યાં સુધી। અને જ્યારે હવે રિયર લાસ્ટ ઇન્ડેક્સ સુધી જતો રહે એટલે ક્યુ ફૂલ થઈ જાય ત્યારે જો રિયર ઇક્વલ્સ ટુ જો સાઇઝ -1 થાય ત્યારે રિયર ઇક્વલ્સ ટુ 0 ઇનિશિયલાઇઝ એટલે સ્ટાર્ટિંગથી રિયરને જો 0 કરી દેવાનું અને જો હવે સાઇઝ હશે એટલે કોઈ એમ્પ્ટી સ્પેસ હશે તો ત્યારે એરે જો કોઈ એમ્પ્ટી સ્પેસ હશે તો ત્યારે એરેના જે રિયરમાં તે વેલ્યુને ઇન્સર્ટ કરી શકશે. અને સર ડિસ્પ્લે પ્રોપર્ટીમાં ખાલી એક જ એરર હતી કે અહીંયા આગળ જે ફ્રન્ટ તે ડબલ ઇક્વલ્સ ટુ 0 લખ્યું છે એના બદલે નોટ ઇક્વલ્સ ટુ 0 કરવાનું હતું, કારણ કે જો પોપ કરીએ આપણે તો સ્ટાર્ટિંગથી ફર્સ્ટ ઇન ફર્સ્ટ આઉટ થશે અને એના લીધે ફર્સ્ટમાં એ 0 નહીં જ રહ્યો, કેમ કે 0 ત્યારે ફ્રન્ટ ઇક્વલ્સ ટુ 1 થઈ જશે. અને જો હજુ વધારે પોપ કરીએ તો 2 થાય 3 થાય, તો એટલે ફ્રન્ટ નોટ ઇક્વલ્સ ટુ 0 કરીશું તો કમ્પ્લીટ વર્ક કરશે ડિસ્પ્લે ફંક્શન. અને પોપ ફંક્શનમાં ફ્રન્ટ ડબલ ઇક્વલ્સ ટુ જો -1 હોય તો ક્યુ ઇઝ એમ્પ્ટી છે એટલે કોઈ પોપ એટલે ડીક્યુ નહીં કરે. ધેન ફ્રન્ટ ડબલ ઇક્વલ્સ ટુ જો રિયર થાય અને જો ફ્રન્ટ ઇક્વલ્સ ટુ જો 0 હોય તો ત્યારે ફરીથી કોઈ એક જ એલિમેન્ટ છે એવું કહે છે, એટલે ફ્રન્ટ ઇક્વલ્સ ટુ -1 અને રિયર ઇક્વલ્સ ટુ બટ -1 કરી દીધું. ધેન એલ્સ ઇફમાં જો હવે ફ્રન્ટ તે લાસ્ટમાં જ છે એટલે કોઈ એલિમેન્ટ તો હવે એને ફ્રન્ટ ઇક્વલ્સ ટુ 0 અને જો કોઈ સ્ટાર્ટિંગના એલિમેન્ટને હવે કરવો છે પોપ તો ત્યારે ફ્રન્ટ પ્લસ પ્લસ એક એલિમેન્ટ એમાં એટલે ફ્રન્ટ જે સ્ટાર્ટિંગને પોઈન્ટ આઉટ કરે તો એને એક એલિમેન્ટમાં એડ કરી દેવાનું એટલે એના નેક્સ્ટ એલિમેન્ટને પોઈન્ટ આઉટ કરશે.
Okay, good. Now see, I am again taking up this entire recap that when we are talking, all the people please switch on your camera. I should not tell again and again. Please keep your cameras on while the sessions are going on. It's always tough to tell again and again to everyone. Okay, so what I'm going to do is I'm going to just give you a recap, right, of all three functions, that how you can optimize this. So the first thing is, when we are talking about circular queue, right, there are functions known as delete and insert. So let's have a look at, first of all, animation of insert in circular queue. Then we'll draw the entire diagram completely. So first and foremost, here we all know that when the circular queue is empty, then both front and rear are pointing to -1. So what will happen is, when we are inserting, let's say addition of 12 in this case, right? So in first case, both front and rear were placed at this particular place. Now, when we are inserting, only rear is increasing. So rear gets increased again and again. Yes, again and again. So this addition is done. Now let's say now we want to delete. At this junction, deletion is just increasing the front. So this front will move to this place. Now if we delete, now again we add, so the rear will increase. So you go on adding, the rear increases. Again you add, okay. At one junction, the rear has reached size -1. So our rear has reached this particular place in your queue. We all know that queue is FIFO, first in, first out. So the element which is inserted first, right, comes out first. So now The point is when I want to insert now, I will have to bring rear to 0 and not rear plus plus. Normally हम क्या करते हैं? We increase the rear to insert, but at one junction point, when rear has already reached size -1, at that point of time, if we want to insert and this place is empty, then we will bring rear to 0. So in this case, when I insert, we bring the rear to 0. So at some point of time, we are not increasing the rear. We are just initializing the rear, right? So that is the entire queue. Now, let us have a look at an optimized code. Okay. सब लोग एक काम करो. I'm giving you 2-3 scenarios. Draw the queue and send me in the WhatsApp. So let's say first scenario is insert. So the queue size is 5, right? You have to draw the circle, right? You have to draw a circle. So first thing is size is 5. Now try to insert 22. This is the first one. First diagram you have to do. I want both front and rear to be displayed. Second diagram I want you to draw is insert 45, 67, 23, 44, 1, 2, 3, 4. And the third diagram is insert 9. Everyone draw the diagram of circular queue and WhatsApp me according to these 3 options. Right? What I want you is draw 3 different circles with this scenario and WhatsApp me.
Sir, are these operations to be done in the same queue?
Yeah,
Like if
same-
we
same
insert
queue.
22,
Same queue. Same queue. All 3 diagrams belongs to same.
Sir, after 44, like once we insert 44, if we try inserting 9, the queue will be full, right?
Yeah, so you will have to draw the queue and write a message that the queue is full. Right? You have to draw the queue and write that message. Okay, WhatsApp me once you have drawn that.
સર પેલી ડ્રાઈવની લિંક બી મોકલજો ને પછી
હા, કઈ ડ્રાઈવની લિંક બેટા?
હા જી સર તમે વિડીયો જે બતાવી હતી ને એ તમે પહેલા કહેતા હતા ને સર
Okay, the animation.
Yes, sir.
Okay, sure. Okay, now check your answers. I am drawing the answer, right? You should be clear about this. So first diagram is, I'm drawing a circle where my Q size is 5. So let's say 1, 2, 3, 4. So one more element I will insert. This is my circular Q, and I'm labeling the index as 0, 1, 2, right? 3, 4. Now, when I say 0 to 4, this means 5 elements. So I'm inserting 22 here. So initially, my two things, front and rear, both will point to 0. So this is the first diagram, answer of the first diagram. Now, second diagram. When I say insert 45, 67, 23, 44. At this point of time, again I draw the same circle with different insertion. Again labeling the index 0, 1, 2, 3, 4. After labeling it, we already inserted 22 and my front is here. So now I insert 45, 67, 23 and 44. So your rear will point here in this diagram. So that is the second answer, that your front is 0 and your rear is size -1. Now when I try to insert 9 at this junction, we see that rear has already reached size -1. So in the third scenario, it will say the Q is, or we can say circular Q is full. Is that clear, everyone? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Try one more diagram. I'm giving you one more scenario. Try one more diagram. So in this case, we have a scenario. Draw the diagram of insert 4, 5. Second, delete. So we delete one element. Third, insert 8. Fourth, insert 9 and 10. E, delete. F, delete. डिलीट का मतलब सेम है, एक एक एलिमेंट डिलीट. H, delete. I, delete. 1, 2, 3, 4, 5, 6, 7, 8 सर्कल ड्रॉ करके दिखाओ कि हर एक सर्कल में सिनेरियो क्या होगा. चलो मेक इट फास्ट एवरीवन.
सर साइज तो सेम ही होगी ना 5.
Size is 5. The queue size is 5, right? Everyone draw this diagram and send across to me in WhatsApp right away.